So why publishing in the first place? And we will hear much more about this subject later. But also from my end, as I have also got some responsibility here at the IFE tool, the first important sentence to say this morning is only what has been published has been done. So you can produce the best results on Earth. And we have had a couple of fantastic students and also scientists who did a tremendous job, had fantastic findings, but they never had either the willing or the power or the ability, whatever you call it, to bring it down to paper. And in the end, there will be somebody else, because there is a healthy competition, sometimes even unhealthy, around the world for the best research results. And in the end, somebody else is going to publish your results. Certainly the results produced in another group, but maybe with similar findings. Let's say you find a new toxin or new metabolite or new enzyme technology to degrade whatever, and you don't publish it, you can bet that at least in a couple of years from now, somebody else is going to publish this, and nobody will remember you. Maybe you don't care that somebody is remembering you, but at least your supervisor will, because otherwise he will probably not approve your PhD thesis. But for your own personal career, it has been a waste of time, because in the end it counts what is your track record. But it's also, it would be a pity if what you have done will not be recognized by anybody. So publish, that's very important. Dissemination and sharing of research results. So it's not only about your own research career, it's also about actually responsibility. I mean, most of us are paid by taxpayers' money. Then you have a special responsibility, certainly also for if you're paid by a company, that's your job. But it's a responsibility also for the community. So when you come up with new findings, share it with your peers. Talking about peers, you can also get feedback from the peers, which is very important. Feedback not only from the peers once the paper is published, but also before it's published, because when you submit your paper, in order to go successfully through the entire approval process, somebody has to read the paper, 2, 3, sometimes even more reviewers, and they will come up with some positive, sometimes even negative criticism, but even a negative criticism is something which you can utilize in order to improve yourself and the paper, and that is a very important feedback which you might not be able to get from your own supervisors, because certainly the more experienced researchers you ask, the more important suggestions you're gonna get. Well, and then kind of linked to what I said in the first place, recognition of your work by the scientific community. So when you go to a scientific conference, you have a couple of papers, you say, well, okay, my name is Rudy. Okay, hi Rudy, so what have you been doing? Yes, I work there and there. Okay, great. They say, well, actually, I have published this and this, and you are in your peer. I mean, don't expect when you go to the city of Tulln and you tell them that you have discovered a new metabolite, that they say, well, I remember your paper. Certainly not, but when you go to a scientific conference, they will say, yeah, I read your paper, and so you are the Rudy. And then you have a recognition and have also a starting point for further collaborations. Also demonstrating originality. So there is a saying, I don't know whether John you know it, they say hardly anybody has got an original idea in his entire lifetime. So it's possibly true, because we are building up our knowledge on the existing knowledge, and a real original idea is really difficult to get. So when you really have an original idea once or twice in a lifetime, you're already good. If you have 10 original ideas, you're already in the category of being a genius scientist. But in the end, originality is important in order to be successful in your submission of papers, because you know there are review papers, there are original papers. and for the original papers, it has to be a new result. And again, getting back to your career, these are important milestones in your scientific career. If you apply for a project proposal to get some funding, if you apply for getting money for a stay abroad, some scholarships whatsoever, you need this track record in order to be successful. Okay, so how do not we perform, but how do countries perform? This is just an example from a decade from 2000 to 2010. You see Switzerland with 176,000 papers in that period, which is a great production, because that's, I think, very important to point out. It's about quantity and it's about quality. So the quantitative parameter is the number of papers you produce, but with originality and with peer-reviewed papers, the quantitative parameter is at the same time also a qualitative parameter, because it has to undergo peer review. You will not be able to come up with 176,000 papers as a country if you are not also producing qualitative good work, which obviously has passed successful peer review evaluation. But even more importantly, for the qualitative aspect is the number of citations. Obviously, what you have published has received the attention of others, and that is why it has been cited quite a number of times. So in Switzerland, these 176,000 papers have received some 3 million citations, which comes up as an average of almost 17 per paper. The United States produces some 3 million papers, 48 million citations. Even more impressive, but citations per paper, well, is in the same order of magnitude as Switzerland. Austria is number 15 in this ranking, with 92,000 papers, some 1 million citations, and citations per paper of around 13, which is not too bad, I would say. But that is, in the end, a very important qualitative indicator, maybe telling you more about the quality of the science done in a country than the university rankings, because with university rankings, that's a special challenge on its own, and does only reflect a couple of parameters which do not necessarily feed into what science is about. I would like to clarify two or three important definitions at the beginning of this course. The first one is the Science Citation Index. So you have often heard probably, so how many SCI papers have you got? So there are papers which are non-SCI papers, and then there are papers which are SCI papers. And as a scientist, not necessary to reach a broad audience, because if you would like to reach a broad audience, it's better to be in the Kronenzeitung or in the Herald, or whatever the name of the newspaper is. But for peer review, for your peers, for the scientific community, Science Citation Index papers are of importance. So this is a citation index which was originally produced by the Institute for Scientific Information, ISI, and owned by Thomson Reuters. So the Thomson Reuters is a very important name to be remembered today, which covers some 4,000 journals in the meanwhile. The larger version, which is the Science Citation Index Expanded, covers more than 6,500 notable and significant journals across 150 disciplines. And the database product provides information to identify the articles cited most frequently and by what publisher and author. So that is very important information you can get through this system, who and what has been published frequently and where. The SCI Expanded is also the basis for the calculation of the impact factor, which is published yearly in the journal citation reports. I will come back to the impact factor in a minute, which is now. The impact factor is a measure reflecting the average numbers of citations to articles published in a science journal. So it's often about, well, okay, citations on the one hand and impact factor on the other hand. Actually, we are mad about impact factors. If I published, or when we publish as an institute, my vice rector for research, he will probably ask me, okay, so you have published some 50 papers. So what is the cumulative impact factor of all these papers? What does this mean? Then I would say, okay, so there is a journal having an impact factor of 3 and another journal having an impact factor of 2. If I publish 2 papers and one it was published in a journal with an impact factor of 3 and another impact factor of 2, the cumulative impact factor was 5. You can also divide it then by 2 and then you have an average of 2.5, etc. So these are the figures of merit or the performance indicators which are of increasing relevance, especially when it's about the university career or in other research institutions. So how is the impact factor calculated? And well, it also says that it's kind of a proxy for the relative importance of a journal within its field. Because, well, if you have a journal has got an impact factor of 4 and then another journal has an impact factor of 2, well, you can easily say, well, this journal is twice as important as the other one. Yes, it's true, it has been, and the average number of citations of this paper is twice than the average citation of the other paper. And that comes now to the calculation of the impact factor. A is the number of times articles published in 2 preceding years, say 2008 and 2009, were cited by index journals during 2010. Yeah, so in 2010, look back to these 2 years. And B is the total number of citable items published by the journals in the same period of year. So this ratio of A, the number of published papers divided by these citations gives you, or the other way around, citation divided by the number of papers gives you the impact factor. So in general, as a rule of thumb, you might say, okay, in a journal having an impact factor of 3, this the average paper receives a number of citations of 3. So 3 times you can expect your paper, if you are in the average line, to be published, to be cited at least 3 times. Well, that is a figure which is an average. You might come up with a much better, or you might end up with a much better record in your own research career, and I will tell you more about this later. But this is a kind of summary of the impact factors. So if you would like to be important, best publish in Nature. Nature has an impact factor of 35, so which means average citations of whatever you publish is 35 times, which is pretty impressive. And you see, actually, the majority of all these papers are either medicine or biology related. You don't see, let's say, you are many analytical chemists here. You don't see hardly a chemist journal here. You hardly see an analytical chemist paper here. We are in the world of, let's say, below 5 or below 10. So hardly, also from the IFA tool, I think we are doing a good work here. Hardly anybody publishes something in a journal having an impact factor of more than 10. Does this mean that we are bad scientists? No. That is why if you are working, let's say, in the discipline of environmental biotechnology, you're not looking into this impact factor list. You're looking into all the journals which are publishing in the area of environmental biotechnology. And then you say, well, you have some 20 journals in this area of environmental biotechnology, and these 20 journals have impact factors from, I don't know, 0.1 to 10. And then you say, well, okay, then there is a 20%, so the best 20% of the papers are having an impact factor of, let's say, 4 to 6, and you are doing well, or also according to the definition of BOKU, if you are publishing in the best 20% of a scientific discipline. And the other important index is the age index, so that's also important for scientific careers. The age index attempts to measure both the productivity and the impact of the published work of a scientist. So whereas the impact factor is about the journal, the age index is about you. The index is based on the set of the scientist's most cited papers and the number of citations that they have received. So a scientist with an index of 10 has published 10 papers, each of which has been cited by others at least 10 times. So an age index reflects actually both the number of publications and the number of citations per publication. So this is possibly tricky. That is why I've put this note in here. A scientist having 2 papers which have been published 12,000 times, so one paper has been cited 12,000 times, and the second paper was published 10 times, has an index factor of 2, an age index of 2. Why? Because this scientist has got at least 2 papers which have been published at least 2 times. Yeah? In order to get to obtain an age index of 10, he needs at least 10 papers. Yeah? So in order to get an age index of 10, he would need 10 papers, and the 10th paper still being cited at least 10 times. Then he has got 10 papers which have been cited at least 10 times. So you see that this is tricky, and especially if you're only single-minded looking into the age index, it does not necessarily show you that you are performing well, because this guy, and this is actually, it happens, has one paper which kind of skyrocketed. So this guy has a paper which, one of these papers was cited at 12,000 times. So that is pretty impressive. But all the other papers were not cited that often, but still, he's a fantastic scientist. So the combination of the age index and the total number of citations, that is what gives you a really good figure or a good estimate of how successful a scientist actually has been writing papers. Hirsch, so that is from the age is coming from, suggested that for physicists, because you can imagine that different areas, as also demonstrated to you with the impact factor before, is very dependent on the scientific discipline. So for the area of physics, a value for age of about 10 to 12 might be a useful guideline for tenure track positions at major research universities. A value of 18 would mean a full professorship. So that is kind of a rule of thumb. So if you ever apply for a professorship, although the committee is aware that the age index, also in combination with the total number of citations, is not the most important thing to consider, you can bet they will consider this, and they will compare it with the scientific discipline you are into, and then they would say, okay, so we are not in physicists, but we are, let's say, in agronomy. In agronomy, actually an age index of 10 is already pretty good. Then that would be something like the threshold. So that is the age index, and that's a very important thing to do. You see here what you can do with the age index, and you can actually easily access this when you go to the Web of Science. So everybody working for university, including BOKU, can go to the Web of Science. And then you have here add author. Let's say you add here my name. And then you click on search. And this gives you immediately your last publications. So starting with 2015, so these are all SCI publications. And then this is a very important click here, create citation report. So when you click on this create citation report, you get, again, almost within the blink of an eye, the published items in each year. So starting here from 1996 to 2015. And you see here the citations in each year. And that gives you, and that is what the committees are looking in. They say, okay, so that's the number of papers this guy has published. This is the number of times you have been cited. There have been 3,144 citing articles who have cited this work. It also shows actually some of the times cited without self-citations. So you see here, for instance, in my case, there's a great number also of self-citations, which is clear. When you publish a lot, you will also cite your own papers. But that's also very important to consider. And then you see, okay, average citations per item, in this case around 20. So your personal impact factor would then be, let's say, 20. And that's your H index 43. And this 43 is actually also shown here on this slide here. I don't know whether you can see this. Actually, it used to be 42 yesterday. It's hopefully right here. So let's say it was 42 yesterday. So you see here on the left side, that's my 42nd paper here. And my 42nd paper was cited 42 times. So that explains to you H index. I've got 42 papers which have been cited at least 42 times. Ignoring the fact that I have some 250 more papers, but that is what the H index is about. In order to get the real impact of somebody, again, you look into the total number of citations. The good thing about this is that you get an immediate impression of how productive somebody is. So remember, I have been cited 5,700 times, H index 42. And then I would say, I'm still not satisfied with my performance. Then you go to Google Scholar, because Google Scholar gives you a much higher H index and much higher number of publications. Why? Because Google Scholar is not only taking into account SCI publications. Google Scholar takes into consideration all the publications, not only those which are in the which are indexed. And you see here on the upside here citations. So rather than being cited 5,700 times, in Google Scholar it shows 8,550 times, and the H index has increased from 42 to 49. Okay, why is this still of importance? Well, certainly you could fake your H index and saying, well, okay, actually I've got an H index of 49, which would be a fake because you would actually have to indicate, well, my Google Scholar index is 49 and my Web of Science index is 42. That's what you will do. But still, I like Google Scholar. Why? Because it shows you the impact of your work beyond the Web of Science. Because you're not only living and working for the Web of Science, you would like to reach a broad audience. And the broad audience is not only those who are reading SCI publications. The broader audience, you would also like to reach a farmer. You would also like to reach some end users who may not necessarily publish and cite your work in an SCI publication, but in a normal article which goes into, I don't know, the chemistry report in Austria. It's still there, and that shows you an additional complementary information on the impact of your work. Google Scholar has also developed an I-10 index, as shown here, which is the number of academic publications an author has written that have at least 10 citations from others. So that's another indication of how you're performing. And the good thing about the Web of Science is also the fact that you are not only able to look or to search for individual authors, you could also put in here an address. So what you can do here is you put in here an address and say, okay, my address is IFA. Anything else would be a little bit more complicated. And I add another field because IFA, there are many IFAs in the world. And I add here Tulln and search for IFA in Tulln, assuming that in all the publications produced by IFA Tulln, IFA in Tulln has been mentioned in the address, which actually should be the case in 99% of the work published. And you can see here, that's the number of items IFA Tulln has been producing over the last 20 years. So we have around 50 publications a year, and you can see also the number of citations. So you see, okay, so what we are doing at the IFA Tulln is obviously of increasing significance because also the number of citations go up to 1,600 times a year. So that's again a great indicator, because if you are sitting in England or I don't know, in China, and you have to evaluate an institute, you can go into the Web of Science and you enter this field, the address, and you can immediately see what's the impact of the institute. And I don't want to leave the message that this is the end of the world and this is the most important thing, age index, number of citations. But clearly, if a scientist, or even worse, an institutions, has maybe got some only 2 or 5 publications a year and is cited something like, I don't know, 10 times a year, even if the guys give a nice impression and everything, obviously something is wrong there, because you need to have at least some impact. You can do the same thing actually to round this off for any area. So you can also put in here a topic. You can say, okay, topic is mycotoxin star. I don't know where the star is now, but it doesn't matter. And you see here okay, so that one does not work. Anyway, I've got here some more examples for you. That is what I was about to tell you online, but that button doesn't work at the moment. You see citation, kind of we could say, well, extract citations report. You can also say analyze your report on the Web of Science. And when you analyze report, it shows you, so you just press the button analyze on the Web of Science, and it shows you the leading authors in a particular field quantitatively. Yeah? So you see here the number of not citations, but the number of papers which have been published in a particular field. So that is another indicator. You could do the same thing with IFA Tulln. How active is a research group, or how active is an institution? Okay, so that was the enthusiastic part of my presentation. Now comes the more critical part. So how important am I standing here telling you that I have so many citations and I have such a great age index? And those who are experts in the area of mycotoxins produced by fungi possibly know Mr. Yoshizawa from Japan. He was the one who, and that's shown here, he discovered the oxynivalenol, the most important mycotoxin besides aflatoxins worldwide, produced by Fusarium. So I looked into this and I was actually curious, how often has this guy been cited? And I was actually very stunned that this guy, and especially this paper, the oxynivalenol, a new mycotoxin formed by Fusarium, was in the last 40 years cited a total number of 95 times. So on the one hand, this is because he had this finding in the 70s. In the 70s, hardly was everybody so mad about publishing as we are now. And the second thing is because he hasn't published, or there was not so many citations back then there was also no kind of an effect of sustainability that authors kept citing this very important paper. So that is actually quite interesting to see that important findings not necessarily end up with a great number of citations. Then we have a guy who discovered not deoxynivalenol, but masked deoxynivalenol in naturally contaminated wheat, Franz Bertiller. So he's already doing quite well because, well, it was a great finding, and he published in the right time, which was in the 21st century. So the masked mycotoxin papers were cited at 186 and at 165 times, which is pretty impressive. So published in the right time, and certainly in combination with a good work is a good combination. Well, leaving the mycotoxin area, polymerase chain reaction, PCR. So that was published by Gary Mullis. I guess many of you know him. And you see this guy has not been very successful in producing papers. Maybe he didn't care of producing so many papers. But he obviously did the right thing with the PCR work. So this PCR work was published 15,245 times, which is really pretty impressive. And which shows that finding a new metabolite or finding a new biological interaction can usually not compete with developing a new method. If you develop a new method, the whole world is able to also apply that method, to take advantage of that method, and they will cite you. So having a new method you will end up in a greater number of citations. But there is another very important factor to be considered. Whether you are successful or not is not necessarily down to citations for a number of reasons which I have already mentioned before. But you can also see that that doesn't necessarily reflect how often a paper is actually read. So I've published in 2012 a paper which summarizes the work Health Canada is actually doing on contaminants, because I worked for Health Canada in that time. And I was pretty proud of that paper because I compiled all the information from the entire research division, and then actually after almost 3 years I looked into the number of citations, and that was actually frustrating to me because I thought it's a good review. And on the top of that, it's a review. Usually reviews are much more often cited. And the number of citations so far is 16. So, well, was it worth the effort? I would say not really, but we'll see how this develops. And actually by chance, I had a conversation with the publisher, which is Springer and Analytical Biological Chemistry. And she said, well, I don't have the impression that this paper has not been successful. I think we have a great number of downloads, and you don't see the number of downloads. So when you publish a paper, it will usually be also online accessible, and then somebody can purchase this paper online. I guess many of you have already done this. So you purchase this paper online, say this might be of interest. And actually the number of downloads in the same period of time was 930 times, which is to me pretty satisfying. And even more satisfying it is for the journals, because the journals, and that is why there is an increasing number of open access journals, the journals have authors who write publications for free, they don't get any royalties. They have reviewers who do the work for free, and then they can sell if for each download they get some $30. So only with my paper they earn some $30,000, and I didn't get a penny for that. But well, certainly it was okay. I get the recognition, and I'm the professor whatsoever. But this is also a very interesting aspect to be considered. But what I wanted to leave as a message here is that there are so many different indicators on how your work might be important and you don't even realize, or even worse, if you would like to go for a career and the others don't realize that what you have been doing has been a great job, you might unjustifiably be ranked as a non-important or non-significant scientist, although actually some indicators say exactly the opposite. So that is my final slide. Based on what I said to you before, how to maximize your impact and recognition as a scientist, and this is also kind of an ironical outlook or summary in a sense. So first of all, choose the right scientific discipline. So if you are in human genetics, nobody can beat you because you will only publish in impact factor journals of greater 10 or so. So how, as a chemist or as an agronomist, no way of getting around this. Publish new methods rather than novel findings. So if you have a method like PCR that's being used all over the world, you can expect many more citations as mentioned before. Do not necessarily choose a high impact journal. So actually in the meanwhile, on the one hand, certainly you would like to publish in high impact journals because you reach also a broader audience with that. But on the other hand, you can receive quite a great number of citations if what you have published is great work. Why? Because now people do not only look into the high impact journals, they Google. So they put in, okay, I would like to know something like, I don't know, stability of DNA in whatever solvent, and then your publication might pop up. And if they find it interesting, they will download it and then they will cite it. So not necessarily is this interest or your recognition based on high impact journals only. Present the most convenient performance indicator if you would like to go for career. Google or Web of Science, Age Index, Journal Impact Factor, total number of publications versus the index. So there's a couple of things to play around with. But I would like to tell you, because it's also this day will also be about ethics on publications. Don't fake anything. The best thing is kind of to really give a committee or your supervisors the impression that you are aware of different indicators, and by pointing out that, well, maybe you're not performing well on this indicator, but there are other indicators which pretty much give you recognition and or reflect your recognition in the scientific community. So I think what I wanted to say is it's important to be aware of different ways of these presentations. Collaborate with many research groups around the world. I think that is for sure a maximizer of publications, not in the faking way, but in the synergistic way. When you collaborate with another research group, like if I would go to Kansas, I immediately, not only because I have more time than being down caught in administrative and management work here, I would I'm sure because of the complementary expertise of John Leslie's and mine, we will come up with a greater number of papers in a shorter period of time. Purchase open access. So that is anyway a very important aspect in many research proposals, that you even have to ask for funding in order to buy your open access. So usually when you publish a paper, it's been published by, let's say, Springer or whatever the publisher is. But then you either have to buy the journal or you purchase an individual article from the web. And that costs you some $30. And if I have some 2 articles which deal with the same subject, and with one is open access, you just download it, and the other one you have to pay, it's complicated, you have to fill forms, you have to transfer money, you would go for the open access one. And that is why it's so important to have as many open access publications as possible, because then with just a click, people would get access. But it's costly. Open access will cost you between 1,000 and 3,000 euro per article. So another thing, you have to write for free, review for free, and then pay that actually your article is online. Anyway, that's the system how it is at the moment. There are now open access journals. These open access journals, they provide open access right away, but in this case you have to pay for the publication. Usually you don't have to pay for the publication. Here you pay something for the publication, then it's open access, and then the other journals do the other way around. So open access is not only good for your career, but actually what you achieve, you would like to be recognized. And that is, open access is a very good tool in order to achieve this. Well, then some ironical statements: publish at the right time. Well, you cannot choose when you were born, you cannot choose when you produce a certain result, but keep that in mind. But when you look at how important a certain publisher or a scientist is. Extract the most convenient statistics from Scopus or Web of Science, also ironic, as I said to you before. Consider all the aspects and present it in the most open way. That is what receives the greatest recognition. Get either a common name or a unique name. So my name is fantastic. So Krska, there's hardly any Krska. R. Krska, you're the only, you click. When your name is John Mayer, I don't know how many thousands of John Mayers, and there is maybe some 50 Mayers who published in the area of agronomy. It's almost impossible to extract the relevant information. You would spend a couple of days in order to get the information. You can certainly play around with filters and with institutions, but it's really difficult to get the performance out of the web, which is, well, a challenge for the committees. Well, most important, and in the first place, publish your good work. Good work and publish. That's what we have to do. If you do good research and if you publish it, then you don't have to take care of any indicators, because in the end you're going to be successful. Especially if you are listening carefully to what John Leslie is going to tell you in the next couple of hours.